Here we have our walkthrough for problem 3. We're told that a small yellow plastic ball rolls off a 1 meter tall table. Here's their ball. And it goes into a 20 centimeter tall coffee can. Here's the coffee can. And how far should I place it away? That's the question. So what is this distance here? We are told the initial velocity is 4 meters per second. And the height of that bar, again, is 1 meter. The height of the coffee can, 0.2 meters, 20 centimeters. So how far does it fall? Well, using subtraction, I can see that the change in height here, delta y, is negative 0.8 meters. Again, conveniently, just like the previous two examples, the initial velocity here is horizontal, so we're really exercising the same skills here. Let's first find out how long it takes to fall 0.8 meters, and we can use that to figure out how far it will travel at 4 meters per second for that amount of time to get the x location for that coffee can. So beginning with delta y, we see delta y, again, where does this equation come from? Y final is equal to y initial plus v initial y times time minus 1/2 gt squared. We've talked before about how this combination of terms comes about from considering the average velocity, combining v initial and v final over some time interval, which we're able to do quite easily if there's a constant acceleration. But we can concatenate or combine these terms into a delta y just by subtracting y0 from both sides. We know vy0 in this case is 0 because it's horizontal velocity, so it begins with neither up nor down component to that velocity. So delta y is again just this third term, this quadratic term, so that's 1/2 gt squared, telling us 0.8 is 0.8 what? 0.8 meters is negative 1/2 of 10 meters per second squared, so that's negative 5 meters per second squared times some amount of time squared. Solving for that time, we see, oh, this is negative because it's falling. This is going to be the square root of 0.8 over 5. 0.8 over 5 is 0.16, so this is the square root of 0.16. Since I know the square root of 16 is 4, the square root of 0.16 is 0.4. Notice, important to consider, when I square a number less than 1, it doesn't get bigger, it gets smaller. Excuse me, not less than 1, between 0 and 1. So t here is 0.4 seconds, probably becoming a intuitive thing that a ball will fall about 0.8 meters in about 0.4 seconds. So how far should we place this? Well, the distance it travels along x at 4 meters per second will be its x velocity times how much time goes by. We can see that that is 4 meters per second times 0.4 seconds, or 1.6 meters.